When it's between me and you, oh Lord, said the train is coming.
Bonjour, ici Alan Rock, recteur de l'Université d'Ottawa, l'Université canadienne. Hello, this is Alan Rock, President of the University of Ottawa, Canada's university. Composez le numéro du poste que vous voulez joindre maintenant ou demeurer en ligne. Enter the extension number you wish to reach now, or stay on the line.
Hey, it's time for the 5 o'clock train. I'm your host, Denis Rancourt, and for the full hour today, we're going to stay with last week's theme, which is global warming. And we have, live from Paris with us, we have Professor Richard Lindzen, who's from MIT, but who's presently in Paris. And we're going to continue this theme. Are you there, Richard?
Yes, I am, Dennis.
Yeah, I'm happy to have you on. I guess we should start with sort of a broad introduction. Give us your climate history. I mean, you were involved with the IPCC, and you've had you're a bit of a turncoat, you might say.
No,
not
okay.
At all right. Well, tell us about it.
I've been working on climate and climate-related issues since the 60s. We were working on the effect of CO2 and so on in the late 70s, early 80s. And we always had the impression that the response was fairly modest. And when the issue became one that in 1988 was promoted as a kind of end-of-the-world issue, we were always offended. The evidence never supported that. And that's the view we've more or less maintained since then, and our research, I think, tends to corroborate that.
Yeah.
Now, at one time, participation in the IPCC, governments selected people to participate, and we did. In the first two as reviewer and contributing author, in the third one actually as a lead author. But like quite a few people in the IPCC, we'd never agreed with the interpretation and spin that was put on the IPCC output.
But you weren't initially vocal about your disagreement with the general political process. That came a little later. Am I right about that?
And what do you mean, the political process?
Well, I mean, the IPCC, as you say, there is a spin. You talked about a spin.
Let's put it this way.
Yeah.
I've always felt there were problems with the procedure.
Uh-huh.
And I think there still are. There are very profound problems. They range from the fact that, it's extremely time-consuming to the fact that it is issued as a statement with the assumption that everyone participating agrees, which they don't.
Right.
So, at the end of the day in these reports, you have 1,000 pages of a report. I think that's not bad. Then you have the summary for policymakers that is issued before the report. And, inevitably reducing that to about 18 pages will skew things a little bit. But, as I've realized over time, even that is not the issue. The whole report gets boiled down to one iconic statement. Could be that, the recent temperature increase is unprecedented. I think that was the second or third one. And then there was, they think it is probable that most of the warming over the last 50 years was due to man. And, the truth is none of these statements was alarming, but they all were interpreted as meaning we must do something instantly.
Right. Is it fair to say that you're one of the main accepted establishment critics of the models and how some modelers tend to overstate what you can get from models, or that they haven't always been used correctly in terms of public policy or suggesting public policy?
Well, remember, they're experimental tools. They have very little skill. So to use them for policy is like using a Ouija board.
Well, that's
but, the first statement you made that, about my being one of the more prominent people, et cetera, I always find that slightly offensive, strangely enough, because there are lots of people in the field, very good people, who have strongly questioned the models, who have acknowledged in the peer-reviewed literature the shortcomings of the models, have demonstrated the shortcomings. And by speaking of me as being, one of the few prominent ones, you tend to marginalize the whole range of criticism.
Well, what I meant by that is that you're one of the few who accepts to come on community radio shows, web broadcasts, and so on. Yeah,
that is a little bit odd, I agree.
Yeah. So, I mean, you're prominent in the uninformed public's view and in the person that is trying to keep track of information through these means.
Yeah, I agree with you that, basically, once you come out and publicly state it, you end up having to restate it a lot of times. I think most scientists would rather avoid that.
Yes. Which is unfortunate, because the public is really interested in this. This is of public interest and of public concern.
Not only that, they're being told all scientists agree.
Yes. Now, so tell us about your evaluation of that so-called consensus. You're saying that there's a lot of scientists who are very critical, and there is not a consensus. Tell us about that.
Well, it depends on what you mean. What you frequently hear in public presentations, even by presidents of the National Academy and the Royal Society, are statements about there has been warming, there is a greenhouse effect, and all scientists agree with that. And that CO2 has gone up, and CO2 is a greenhouse effect, gas rather, and its increase would cause temperature to increase, all other things being equal. And, the truth is that is something that most people involved in this subject agree on. My point has simply been none of that points to alarm.
Right. But we were talking earlier about how there are several people who are critical of the models, the global circulation models.
That's a separate issue.
Yes. But
in other words, for instance, some models tend to predict that a doubling of carbon dioxide could give you, let's say, 5 degrees centigrade warming, average anomaly over the Earth. That probably would be a matter of concern. But that statement does not follow, for instance, from the statement that most of the warming over the last 50 years is due to man's emissions. The correct statement is, if the models are right, they've actually accounted for 2 to 5 times the warming we've seen, and that the difference has been canceled by unknown effects, which they refer to as aerosols.
Right. Well,
and I think the public would find that less compelling.
Yeah. Yes, I'm starting to see your point. Now, let's come back to something you just mentioned. You said some models would predict that if we double CO2, we might get a warming, a global average warming as high as maybe 5 degrees Celsius.
Yeah.
And you said that might be of concern. What is the evidence, what is the empirical evidence, or what reason do we have to believe that, if we were to observe it, would be of concern?
It's a good question.
Yeah.
It's a good question. I mean, all of us certainly deal with bigger changes in temperature, especially in Ottawa.
Yes.
Bigger changes in temperature in the course of a day. And very few phenomena depend just on temperature. So the connection even of that to catastrophes is a little bit obscure. Now, the argument often is made that, for instance, during the cycle of ice ages, the change in global mean temperature anomaly is also on the order of 5-7 degrees. And so they're saying changes in mean temperature of 5-7 degrees can be associated with major changes in climate. But what's forgotten in that is the real change between ice ages and the present, the glaciation cycle, are changes in the equator to pole temperature difference that can be 30 degrees in winter. And that's huge compared to the mean, and the mean is a residue of that. It isn't what drives that.
So let me just clarify that for our listeners. You're suggesting that the difference between an ice age and a regular warm period in Earth's history is the magnitude of the temperature difference between the pole and the equator, let's say. Is that right?
I'm saying that characterizes the difference.
Yeah, that's a more...
That can be 20, 30 degrees.
So that's a more important indicator. It's a more direct indicator.
Exactly.
So,
and the tropics remain relatively stationary. It's the polar temperatures that change dramatically.
And so they get much colder during an ice age. Is that the point?
Right.
And so therefore that difference between the equator and the pole is increased dramatically during an ice age.
Absolutely.
And you're saying that temperature difference, pole to equator, is a really good indicator of something as dramatic as an ice age, which is a global process involving a lot of snow and ice, a change of albedo and so on, right?
Well, mainly ice volume.
Okay. Oh, tell us, why? How do you mean mainly ice volume?
Well, I'm saying that, albedo is something people easily glob onto. But actually, the models, I think, have that right. They get very little effect from the albedo. Albedo is reflection of sunlight from the snow and ice. The reason they get so little is, for fresh snow, that's primarily in the winter. And in the winter at high latitudes, you don't have much sunlight anyway. And in the summer, if you have an ice sheet and you develop puddles on it, that's almost as though you don't have any ice as far as reflection goes.
Right.
On top of the whole thing, you always have clouds in the Arctic, and they tend to reflect whether you have snow below or not, and you don't see through the clouds.
Okay. And so how does ice volume... why is that important?
It's an indicator that you have accumulated a lot of ice.
Okay, but are you suggesting, for example, that you've accumulated a lot of ice, therefore the ice has gone down towards the equator, and therefore there's an albedo effect because of that?
There's some, but I mean the main thing with the ice ages is the change in the orbit of the Earth.
The distance, the effective distance from the...
Not so much distance, but the tilt of the axis,
Yes. So tilt towards or away from more land mass on the planet. That's the idea?
Yes, where the Earth is when the axis is tilted toward the sun and so on.
Uh-huh. That's the driver as we understand it. Yes.
Yeah. Remember, when you average over the Earth, the orbital changes give you almost no change in radiation.
Right.
But as a Serbian astronomer in the 30s pointed out, if you look at what's important for ice growth, it is the amount of sunlight reaching the Arctic during the summer. And that changes by 50 watts or more per square meter. And remember, doubling CO2 is a change of about 3.7 watts per meter squared. So the orbital change, where it counts in summer in the Arctic, is huge compared to the changes due to CO2.
And it counts there because that's where you can start accumulating ice?
Whether ice grows or not,
right,
is the sunlight in the summer. If it's less, then the ice can accumulate.
Okay.
If it's more, the snow that falls in the winter melts.
Okay. I'm going to bring you back before our first break. I'm going to bring you back to that question Why
Okay.
would even 5 degrees Celsius, even that much in the average global temperature, why would we be concerned about that? What is a reason to think that ecology and human life on the planet would dramatically be transformed?
Oh, let's get back to that.
Yeah.
Tell me when.
Right now.
Okay. I made the statement glibly. The reason I made it is, in the track record of temperature, such a change would indeed be extremely unusual. What we've been looking at for the last 100 years, or even probably for the last 1,000 or 2,000 years, are changes on the order of a fraction of a degree, maybe a degree or two. So 5 degrees would be unusual. That's the primary reason that I said it would probably warrant concern. The connection with life as we know it, I mean, that has to be considered an absurd statement, except if you mean as we know it to be exactly the same as today. Human beings have been able to settle places with hugely different climates. And the notion that they would not be able to adapt to that is really pushing things very hard.
But
also,
yeah,
the whole notion that, when I spoke of the equator to pole temperature difference
yes,
being 20, 30 degrees greater in a ice age, a glaciated winter, the change in global mean temperature is the small residue of that big change. It's a little bit implausible to argue that the residue drove the phenomenon. It's a residue, after all.
I'm with you. So, if I understand you correctly, you're saying that you can't tell us why we should be concerned about even 5 degrees, which is on the high end of even what is being predicted. There's no one out there, a field scientist or a theorist, is able to tell us, look, if this residue increases by 5 degrees...
How should I put it? Let me give you an example.
Okay.
I noticed that every few years, the alleged danger of warming changes. So, for instance, for a few years, you remember it was the iconic picture of the stranded polar bear. The last year or two, it has been extreme weather. Now, extreme weather is kind of interesting because where we lived, either Boston or, for that matter, Paris or Ottawa, if you look at extremes of weather, they occur usually because air is advected either from far to the south or far to the north. That is to say, very cold air comes over Ottawa if the wind is blowing from the north. Very warm air might come from the south. Okay?
Yeah.
So the range of change depends on the equator to pole temperature difference.
Right.
If there's a big difference, you can get bigger extremes.
Yes, because that temperature difference would drive these air mass movements.
Right, and it's also the temperature of the extreme differences that represent the extremes you see when it blows over you.
Yes.
Now, in a warmer climate, it is usually argued that the pole will warm more than the equator.
So you'd be...
that reduces that difference in temperature between the equator and the pole, right?
Yes.
That should have the opposite effect of increasing the variability in the extremes and so on.
Now, I'm sure when you say that to scientists and modelers who have been using the spin that we hear about in the mainstream media, they would be upset about that. How would
No.
they respond?
No, I don't think so.
How would they respond?
I think actually most models agree with that.
Yes, I know, but but the fact that you're pointing out that the conclusion has to be different than the one they're going along with.
They're not saying that the models actually produce that. That's a scare statement. And the reason the correct statement isn't made is because it's felt not to be scary.
Are you saying that scientists go along with this?
How should I put it? Scientists are in an awkward position on this issue. I mean, at least in the States and in Europe, there is a government monopoly on science. And you, as a scientist, depend on grants from the government. You're always competing with other fields in order to argue that your field is more important and worthy of more support. You have to do something that grabs public attention. In this case, you had a confluence of interests between the green movement, politicians, and the scientists. But I don't think the scientists initially, following their usual instinct, like war on cancer and so on, to over-dramatize their area, figured that they would be entering into a multi-trillion-dollar issue, which would involve changes in the whole energy picture, huge taxes, and so on. But once it happened, you were kind of stuck in it, weren't you?
Yeah. And
you can't then say, oh, we were exaggerating.
I see your point. There's a point of no return there. And so you'd be sticking your neck out to start arguing in order to slow this thing down.
Yeah. I mean, the field has grown immensely. I mean, in the States, for instance, the first President Bush increased the funding from something like $170 million a year to something like $2-3 billion a year.
Uh-huh.
The field couldn't absorb it, so you had a huge number of people entering who had no other interest than responding to that increase.
Right. I just want to remind our listeners that you're listening to the 5 o'clock train. I'm the regular host, Denis Rancourt, and we're in conversation with Professor Richard Lindzen, who is still a professor at MIT, but right now he's in Paris. Why are you in Paris?
I like Paris. My wife is French, and there's a lab here that kindly hosts me to the extent I need that. But it's also, MIT has a process where prior to retirement, you're freed of teaching responsibilities for a few semesters. And so I'm going to retire a year from now. And in the meantime, I have more freedom than I usually had.
Very nice. And we're going to take our first music break. And you have suggested a group called Sacré Bordé. I don't know now. Well, I'm starting to know that now that I know your wife is French. Is she from Brittany, actually?
No.
Okay,
we just like Dalil.
Okay, Sacré Bordé. This first song that I've selected from your suggestion is called La Plage de Moustérien, or Moustérien. Tell us about the song. Do you know that particular one?
I don't know about it. I just like listening to them.
Okay, so this is French music from Brittany. And this particular song is about arguing for which is the most beautiful beach in the world. And I think it's a beach in Brittany. So we'll play that in just a few minutes, and we'll be right back, and we'll continue our fascinating conversation. So stay with us, and we'll just play that. We'll be right back. And we'll just get that underway. Here we go.
Et les plages de Rio, les plages de Bornéo, elles ne valent pas vraiment la plage de Moustérion. Et les plages de Paris ou les plages de Capri, elles n'ont pas la beauté des rivages de Célé. Monsieur de Lannoy, qu'a des super idées, a fait venir du sable, a créé Paris-Plage. Et pour faire son chantier, il s'est bien inspiré. Il a pompé des plantes, la plage de Moustérion. Et les plages de Rio, les plages de Bornéo, elles ne valent pas vraiment la plage de Moustérion. Et les plages de Paris ou les plages de Capri, elles n'ont pas la beauté des rivages de Célé. Alerte à Malibu, ça a coûté des sous pour voir toutes ces beautés. Chirurgie plastiquée, aujourd'hui on préfère, ce n'est plus un mystère, montrer de l'authentique et des lieux plus rustiques. Et les plages de Rio, les plages de Bornéo, elles ne valent pas vraiment la plage de Moustérion. Et les plages de Paris ou les plages de Capri, elles n'ont pas la beauté des rivages de Célé. La Méditerranée.
Bridgehead is celebrating a decade of serving great coffee and tea to the Ottawa community. Bridgehead supports small-scale farmers by offering 100% fairly traded and organic coffees and teas. Their commitment to social responsibility means grower families receive more money for their coffee, and cooperatives receive more money for special projects chosen by the community. Bridgehead wants to thank you for your support over the past decade and looks forward to serving you a tasty coffee, tea, and freshly baked good at one of their 12 Ottawa locations.
Hey, we're back. This is the 5 o'clock train. I'm your host, Denis Rancourt. We're in conversation with Richard Lindzen. And I want to remind our listeners that this show gets podcast. It's archived on the blog of the show, trainradio.blogspot.com. Trainradio, one word, .blogspot.com. You can contact us there if you have feedback or questions about the show, criticisms, whatever you like. And we're back now with Richard Lindzen. Welcome back.
Thank you.
I also had a look at your slides for a recent presentation, which I guess you made in Paris. Is that what these slides are for?
Yeah, they probably were.
Okay. Well, the presentation is entitled Physics, Climate, and Models. And you make some very interesting points there that one in particular, which I think is one of your main points, and that is that we're using these models only one way. We're comparing with some average measurements, period. We're not using them to actually test the scenarios and the time variation of scenarios in order to see if the measurements of what's happening on the planet are also correct and if there's self-consistency there. So you're doing this criticism that we're kind of like not using these tools fully. Am I right to...
I think that's true. I mean, the Intergovernmental Panel on Climate Change mainly engages in comparing models with each other.
Yes.
Not even with the data per se. And, you know, the test quote, I don't regard it as a test, is can you make the models simulate some feature of the observations? And you always do that with adjustable parameters. So it's like taking a test and knowing the answer in advance.
And these global circulation models, which are the ones they use now more recently, do you see some major structural flaws in the models themselves?
Yeah, sure.
What would be some of your main criticisms in those terms?
The main concern, I mean, there are lots of concerns. They're very bad for regional weather, regional climate. They don't seem to get things where they're supposed to be. They're not terribly good on seasons. They're miserable on long-term internal variability, things like the El Nino cycles, things like the Pacific decadal oscillation, the Atlantic multi-decadal oscillation. These are known phenomena. And the models don't do a good job on those.
Do the models even have jet streams in them?
Oh, yes.
Okay.
They
so
do.
At least that's there, because I think jet streams are important for regional changes, right?
Oh, yeah, but the bending of the jet stream tends to be wrong.
Uh-huh.
And in addition, for climate, the feedbacks are all important. I mean, doubling carbon dioxide alone would give you about a degree if you doubled it.
Alone meaning without any feedbacks or anything
Right.
else being changed. Right.
Any feedbacks either amplifying or diminishing the effect.
Right.
And in the models, you have the odd circumstance from an engineering point of view of them being dominated by positive feedbacks. So whatever man does with his emissions in the models gets amplified quite a lot. Usually 2 to 4 times.
That is, for anyone with an engineering or science background, that is highly counterintuitive.
Absolutely. Because what it means is, these feedback processes involve clouds. And the way clouds behave depends on all sorts of other things. So the feedback factors themselves are subject to fluctuations. And once you get to something that amplifies the response by a factor of 4, the smallest change in the feedback factor can take you over the top into an unstable regime. And the thought that the Earth survived for billions of years as such a system just is grotesquely implausible.
I just want to clarify this. There's a subtle point in what you just said. You're saying that when you increase the amount of positive feedback, you're also dramatically increasing the system's sensitivity to a change of that positive feedback. Is that
Absolutely.
So you're saying that if we're going to believe such a large positive feedback, we have to admit a high sensitivity to the feedback itself.
Yeah, that is subtle.
Yeah.
I mean, in other words, the feedback you normally think of as fixed.
Uh-huh.
You change the temperature and the clouds change in such a way as to either amplify or reduce this.
Right.
But in fact, that depends on the brightness of clouds. And cloud brightness can often depend on aerosols, on what caused the clouds to form, to condense, to do all sorts of things.
Mm-hmm.
And these are quite variable. So if you had a feedback factor on the average, such as to magnify the responsive factor of 4, it would take only a little bit of change in that feedback factor to bring you to infinity.
Meaning a sensitivity of infinity, meaning a really dramatic increase in temperature.
Yeah, it would take time for it to happen, but, over billions of years, it would be hard to think that the system would have been sustainable with or without man.
Right, because even the response times are usually only 100 or 1,000 years. Am I right about that? Okay.
Yeah.
So this point is a very interesting one. Are there a group of people who have put forward this criticism, or is that
we sort of put it in a paper a couple of years ago trying to explain something called the early faint sun. I don't know if you've ever heard of this phenomenon. This is really going back quite a ways. If you go back about 2.5 billion years ago, we're pretty sure that the brightness of the sun was about 30% less than it is today.
Okay.
20-30%. And remember, again, a doubling of CO2 is a change of 2%.
Right.
In the radiative budget.
As an equivalent effect with present models.
So now you have 30% reduction.
Uh-huh.
And the geological evidence is that the temperature of the Earth was not very different from today's, and that the oceans were not frozen.
Right.
And we argued that this could only happen if the Earth water cycle provided a negative rather than a positive feedback.
Okay. We're getting some echo now. Has something changed on your side?
Yeah, I'm hearing it too.
Okay. All right. We'll just continue and see how it goes. Yes, I interrupted you. Go ahead.
Okay, well, all I'm saying is to resolve the paradox of the early faint sun requires only a modest negative feedback, but it would be almost impossible if you had a positive feedback.
Say that again, or say it in a way that I can grasp it more.
Okay. The situation is...
I understood the scenario where, the sun was a lot weaker.
The question is, why didn't the Earth freeze over?
Yes.
And we've argued that it would be, well, other people have argued that it's virtually impossible to prevent the freezing by increasing greenhouse gases.
Okay.
People have tried methane, CO2, and so on.
Right.
The amounts you would have to add would be so monumental that the geological evidence rules it out.
Okay.
So the question is, how did the Earth prevent freezing when the sun's brightness went down that much?
Yes.
And we've argued that a very easy way to prevent it is just to increase the upper-level thin clouds in the tropics. And you don't have to increase them even to get total coverage to prevent this freezing over.
Uh-huh.
But in order for them to behave this way, the feedback has to be negative. It has to counter the effect of the reduced brightness of the sun. It can't amplify it.
Okay, but what's wrong with saying, well, okay, under conditions where you bring the power of the sun down, the feedback is negative, and under present conditions, the feedback from the water cycle is positive. What's wrong with that?
That isn't the way things work. It either, positive... The question is, does the process act to resist change or amplify change?
Right.
And so the notion that it resists it when you want it to resist it, and it amplifies it when you want it to amplify it, is a very peculiar system. I wouldn't know how that would work.
So you're saying you could not, in your mind, devise a mechanism with what you know about the hydrological cycle where that would be possible. Is that what you're saying?
I can't.
Okay. And has this criticism had some sway?
Hard to tell.
Okay. Something happened last week when we interviewed Ray Pierre Humbert.
Yeah?
He didn't have only nice things to say about you. He suggested that you don't understand physics and have never made an argument that he thought was rigorous in terms of the physics, and that if you had a good argument, you would put it out in a published paper, and it would stand up to physicists critiquing it.
That seems a bit odd. I mean, I've published a lot of this.
That's just something he gratuitously threw out there in your direction, so I wanted to give you a chance to respond.
Well, the thing I just spoke about was the Journal of Geophysical Research. I have to say, I mean, it was a kind of cheap shot, because one of the things that lots and lots of scientists have complained about is if you do write a paper that questions the danger scenario, you do have a hell of a time getting it published, and almost all such papers have to be watered down. But the papers I'm speaking of have all ultimately been published.
Are you saying that in the present context, it's more difficult for scientists to be critical of sort of the alarmist position?
Of course.
Really?
Oh, yeah. I mean, look, years ago, already more than 20 years ago, I wrote a paper in the Bulletin of the American Meteorological Society in which I laid out some criticisms of the alarming scenario. And they did publish it. It was reviewed extensively. The questions were answered. It was published. The response was extraordinary. The first thing is the editor got fired. The second thing is I got a letter from the president of the American Meteorological Society, at that time Joanne Simpson, saying that someone who had received prizes from the American Meteorological Society shouldn't write a paper like that. And what is most odd is when this person retired from NASA about 6-7 years ago, she publicly acknowledged that she also questioned the warming scenario.
Wow. So there is a culture that, don't do anything that would harm this sort of the, what do you call it, the gravy train or the grant?
Whatever it is.
Okay.
There's no question. That,
wow.
It's felt to be essential to the welfare of the field.
Oh, my. Well, that's frightening on its own. I mean, you should almost write a sociology paper about that.
Well, maybe you bring up actually a curious point. There is a field called science studies, which basically is social scientists investigating how science works.
Yes.
And they're usually very critical of science. And they won't touch this subject.
Wow. That tells you something right there. There's a lot of money involved. Not just careers and grant money, but also, as you said,
Look, the carbon trading market will be if it ever comes to fruition, will be one of the largest commodity markets ever known.
Yes. Planetary scale.
Alone are likely to be tens and maybe hundreds of billions of dollars.
Yeah. I think we should take our final music break. And when we come back, I want to chat about, you were making the point in this presentation that if you look at the data and use the models, you can actually conclude the opposite of what's being assumed in the models. And so I'll read the paragraph from your presentation.
Yeah.
We'll discuss that at the end.
Better read it to me because I'm not sure I'm familiar with what you're saying.
Right. I think when I read it to you, you'll know exactly what I'm talking about. But I'm going to play again from this group Sacré Bordet. I wonder if you know this one. It's called Dicton Breton.
You've picked an album I'm not familiar with.
Okay, that's fine. Anyway, I found them quite beautiful, and I'm going to go ahead and play this one. But what did bring you to this group?
Oh, we just heard them when we were in Brittany a few years ago. I enjoyed them.
Uh-huh. Did you dance to it?
To it?
Did you dance to this music?
Oh, yeah, there was dancing to the music.
Yeah. Great. Well, we'll play that, and we'll be right back, so stay with us.
En Bretagne, y a des marées.
En Bretagne, y a de l'air salé.
Y a aussi des monts d'arrêt.
Et des bois où y a des fées.
C'est là que sont les Bretons.
Avec ou sans chapeau rond.
On écoute leurs chansons et on écoute leurs dictons. Comme disait le laboureur en ouvrant grande sa fenêtre. Si l'horizon n'est pas net, faut rester à la buvette. Comme disait le bon fermier, avant que ne tombe la nuit. Dès que le merle chante en mai, c'est qu'avril est bien fini.
En Bretagne, y a les marées. En Bretagne, y a l'air salé. Y a aussi les monts d'arrêt. Et des bois où y a des fées. C'est là que sont les Bretons. Avec ou sans chapeau rond. On écoute leurs chansons et on écoute leurs dictons.
Comme disait un cafetier, quitter d'être bourré. Ceux qui boivent pour oublier, l'avance est trop bien payée. Comme nous vous le savez, boire au volant c'est pas bien. Mieux vaut boire à la bouteille pour connaître d'autres matins.
En Bretagne, y a les marées. En Bretagne, y a l'air salé. Y a aussi les monts d'arrêt. Et des bois où y a des fées. C'est là que sont les Bretons. Avec ou sans chapeau rond. On écoute leurs chansons et on écoute leurs dictons.
Typisme ménage chez bon, nous disent les mariniers. Qui sauvant te rincent les dents et vivent les coins aérés. Si mauvaise météo, la journée sera au bistrot. Si la mouette est sur le mât, bientôt viande sera sur toi.
En Bretagne, y a les marées. En Bretagne, y a l'air salé. Y a aussi les monts d'arrêt.
The Lieutenant's Pump at 361 Elgin Street has long been a favorite gathering place for many a fine folk in Ottawa. More than a well-stocked watering hole, the Lieutenant's Pump is famous for its weekend brunch, Sunday roast beef dinner, and Wednesday wing night too. Groups can meet in the back room, two can dine in a cozy nook, singles feel comfortable chatting at the bar. In the best sense of the word, there's something for everyone. When you're thinking about where you'd like to go, try the Lieutenant's Pump, 361 Elgin Street at Frank.
Hey, we're back. This is the 5 o'clock train. I'm the host, Denis Rancourt, and we're in conversation with Richard Lindzen. Welcome back, Richard.
Okay.
So I wanted to know more about this point you were making in a recent presentation. And the way it's stated here in your slides is, we see that all the models are characterized by positive feedback factors associated with amplifying the effect of changes in CO2, while the satellite data implies that the feedback should be negative. Yeah. Similar results are being obtained, and so on. Yeah, what is that? What is that about? Tell us about that.
In general, let's say we didn't have an atmosphere.
Yeah.
And you heated the surface a certain amount. You expect that the outgoing radiation would increase by a certain amount, viewed from space, to, just resist it.
Yes, it would. The surface is hotter, therefore it's radiating more.
Yeah.
And it'll only heat to the point where you're radiating as much as what is coming in.
Right.
Yeah.
Now, the surface of the Earth is always fluctuating in temperature.
Yeah.
Even in the mean. A few tenths of a degree here and there. Okay?
Okay.
And so, if you observe outgoing radiation with a satellite, you would expect, if the feedbacks are positive, that you would see less outgoing radiation for each change in temperature than you would if there were no atmosphere, no greenhouse gases, etc.
Right, that's during the process before you reach the new steady state. That's
right,
when you're actually just after you make a change, right?
Exactly.
Yes, okay.
Now, you have to be careful because all these things fluctuate. The data is hardly perfect. But if you do what is called lagged correlation, in other words, there are fluctuations, but you want to concentrate on those fluctuations that follow the change in temperature rather than precede it.
Uh-huh.
Then what you find is that instead of getting less radiation out, you get more. Which is to say, the system cools more efficiently than it would in the absence of
Okay,
an
so that dynamic response that you're getting, that you're going to look at in the models, is telling you that the feedback is actually negative rather than positive.
I'm saying in nature you see that.
Yes.
If you do the same thing with the models, they get less radiation, predict less radiation comes out.
Even
so
dynamically?
Consistent with the positive feedbacks in the model, but I'm arguing that is not what you see in nature.
Okay, so so they're both dynamic situations now. You haven't let the system have time to come back, and you're saying in the model, the way they're constructed, they're consistent with what they're saying. They're okay.
Absolutely.
But you're saying actual field measurements from satellites show the opposite.
Exactly.
That's what you're saying. Aha. Well, that sounds important.
Yes, I think it is.
I mean, it's an actual field measurement of the feedback.
I mean, you have to realize, to be fair, in atmospheric sciences, these measurements are not easy.
Right.
They're noisy. And there's always some reason to at least be a little bit concerned about their accuracy.
Mm-hmm.
But this looks pretty solid.
Okay. So we've got satellites properly calibrated, looking at the right thing. The experts that are doing this think they're doing it right, and you're seeing...
Now, there have been studies that claimed the opposite, although not very significant positive feedbacks. But those generally did not look at any distinction between random fluctuations in radiation and those that lagged the temperature.
Right. So it's important to because
to distinguish fluctuations that force temperature changes from those that respond to it.
Right. And a key scientist's name who's actually doing these field measurements, is that Roy Spencer?
Spencer is one.
Uh-huh.
There have been other people, Oster and Gregory, Dessler, who have claimed different results, but none of them have properly accounted for the lag.
Right. Well, this sounds like if we're going to be concerned about global warming, and if we need to address the question of feedbacks, this is how you measure them.
It's one way.
Right.
There's another way we're working on,
Uh-huh.
which is to look at how evaporation changes with temperature. And that would be a little bit harder to explain, but that should in fact reflect the changes at the top of the atmosphere. And it's been pretty well established that, for instance, the changes in evaporation with temperature are considerably different in nature than in the models.
Mm-hmm. And are these satellite measurements also?
Partly.
Uh-huh.
It's very hard to measure global evaporation.
Yeah.
And the way it's done is to infer it from satellite measurements of wind and observations at the surface and so on.
Mm. Well, they're asking difficult questions, and they're claiming things that are important to us and how we live, and so we have to get into those difficult measurements to answer,
I
guess.
So.
Yeah.
I think it really, one of the points I've made is that one has to begin testing rather than defending the models.
Right. There's a novel idea.
Yeah.
I want to go to another theme now. Maybe we can end on this one because the hour is coming up. This idea that warming would be associated with extreme weather, and they're using this mathematical notion of chaos to make that argument. Do you see any support for that? Where's that coming from?
You're saying they're arguing that chaos.
Well, that the mathematical concept of chaos is being used to argue that if we have a little bit of an increase in the average warming, that this will potentially give us extreme weather.
How shall I put it? That statement is so vague. The chaotic notion, the chaotic quality of climate is worth investigating, but it is hard to prove. And the notion that is the danger, I don't know of any basis for that whatever.
Right. Are you suggesting that we should stop worrying about global warming?
No, I would say that at present that would not be a bad idea, but that has a policy issue. And the reason I say that is no one has come up, let's say I assume the worst, that the sensitivity of the climate is very high, and that the association of disasters with that change in temperature is correct. The question then is, are any proposed policies likely to do anything about that? And so far, the general conclusion is whatever has been proposed, although it will have major effects on the economy, will have almost no effect on climate. Regardless of what you believe about climate.
Pierre Humbert was adamant last week that was not the case. If we were to go nuclear, and if we were really serious about cutting out fossil fuel burning, that somehow that would make a big difference.
And if you knew how to do that, that would be great. We could go nuclear. We could use nuclear, I suppose, to make fuel cells. It would increase the cost of energy immensely. So even if you were able to achieve that, it would not be free. I'm not sure where he's coming from because, there are loads of estimates on that coming from each direction. But that is not the policy that's being proposed anyway.
Right. Well, we only have a few minutes left. How would you like to end this?
I'm not sure.
Well, your main point in your recent presentation is that, I guess you put it this way, we've got to stop comparing models with models and data analyses with data analyses. And we've got to go back to trying to do science how it was intended. I'm paraphrasing.
Also, to introduce basic theory, regardless of what Ray says.
Yeah. How do you mean?
In other words, I make the point in what I sent you. There are some things the models get right. Mm-hmm. And there is one of the things that they get right, because we know why, is that if you are warming the Earth, the maximum rate of change occurs, about 10 kilometers above the surface over the tropics. And the reason we know that's right is that follows something called the moist adiabatic lapse rate. The data does not confirm that. And so I would argue there that the models are right and there's something wrong with the data.
Is that because you know the problems with collecting this data? How are you?
It's because the data is violating a basic physical principle.
Oh, so we've got to really bear down and examine everything that's happening here. That's what you're saying.
Yeah.
Uh-huh.
I mean, the data we know isn't perfect, and we have to have some criterion for testing the data as well. And in at least a few cases, we do have basic theory.
Right. Okay. Well, what are your words to end this hour now? How do you want to?
I don't know. I suppose the answer would be to at least reserve judgment and not do anything too stupid in the meanwhile.
Okay.
And some of these policies do seem that way.
Right. Well, how do you feel about the so-called precautionary principle?
It's incoherent.
Oh, that's a beautiful way to end the show.
I mean, the precautionary principle says don't do anything, including take action on a precautionary basis, because it too may have dangers.
That's right. Okay. Well, it's been wonderful having this short hour with you, Dr. Lindzen. It's been great. Thank you. It's late there in Paris, and I imagine you're going to bed soon.
Yes, I am.
All right. Well, have a nice evening, and thank you very much for doing this with us.
My pleasure.
Bye-bye now.
Bye-bye.
Okay, so we're going to end with the music that we didn't have time to play with as a transition song last week. We tried to. It's the Bastard Fairies, and it's called Whatever. And here it is again.
I've got to save the world, liberate, eat the food that's on my plate. Recycling is really great. Whatever I can do to get in bed with you. I'll be a Marxist, a communist, a pacifist, an anarchist, a Democrat, red, white, green, or blue. Whatever I can do to get in bed with you. I never knew I gave a damn until you told me who I am and what to do. Whatever I can do to get in bed with you. 'Cause I know war is bad and love is really good. Taking a stand starts in your neighborhood. I do the best I can, just like you say I should. The ones who make a difference